Hello and welcome to How to Econ. In this video, we will consider the topics of the perfectly competitive market, such as how perfectly competitive firms make decisions about how much to produce, how much profit they make, and whether to stay in business or not. First, let's take a look at the structure of a perfectly competitive market. It has 1. Many firms produce identical products. 2. Sellers and buyers have all relevant information to make rational decisions about the products that they are buying and selling. 3. Transaction cost is almost zero. Think about it as it's almost effortlessly or super easy for a consumer to switch among sellers or for sellers to sell their products to different customers. 4. Firms can enter and leave the market without any restrictions. In other words, there is free entry and exit into and out of the market. Finally, there are so many sellers and buyers in the market that the pressure of competition forces them to accept the prevailing equilibrium price in the market. For example, if a firm in a perfectly competitive market raises the price of its product by so much as a penny, it will lose all of its sales to competitors. Or if a consumer doesn't want to pay for the market price, sellers do not have to lower their price because there are so many other buyers who will buy their products. We call sellers and buyers in a perfectly competitive market price takers. Since a perfectly competitive firm must accept the price for its output as determined by the product's market demand and supply, it cannot choose the price it charges. Therefore, a perfectly competitive firm has one major decision to make, which is what quantity to produce. When the perfectly competitive firm chooses what quantity to produce, then this quantity, along with the prices prevailing in the market for output and inputs, will determine the firm's total revenue, total cost, and ultimately level of profits. The maximum profit will occur at the quantity where the difference between total revenue and total cost is largest. Keep in mind that in the short run, a perfectly competitive firm will seek the quantity of output where profits are highest, or if profits are not possible, where losses are lowest. In the long run, positive economic profits will attract competition as other firms enter the market. Economic losses will cause firms to exit the market. Ultimately, perfectly competitive markets will attain long-run equilibrium when no new firms want to enter the market and existing firms do not want to leave the market as economic profits have been driven down to zero. The approach that we described in the previous section, using total revenue and total cost, is not the only approach to determine the profit maximizing level of output. Now we will see an alternative approach which uses marginal revenue and marginal cost. Firms often do not have the necessary data they need to draw a complete total cost curve for all levels of production. They cannot be sure of what total cost would look like if they, say, double production or cut production in half, because they have not tried it yet. Instead, firms experiment. They produce a slightly greater or lower quantity and observe how it affects profits. This approach to maximizing profits means examining how changes in production affect marginal revenue and marginal cost. Marginal revenue is the additional revenue gained from selling one more unit. It equals the change in total revenue divided by the change in quantity sold. Marginal cost is the cost per additional unit sold. It equals the change in total cost divided by the change in quantity sold. A firm's profit happens when marginal revenue equals marginal cost, or at a choice as close as possible to that point. Let's take a look at an example of a raspberry farm. In this example, the graph on the left shows the market demand and supply for raspberries. The equilibrium happens where the market price is $4 per pack of raspberries. The graph on the right shows the marginal cost and marginal revenue curves of a raspberry farm. As mentioned before, a firm in perfect competition is a price taker. It can sell whatever quantity it wishes at the market-determined price. That means it has to sell its raspberries at the given market price of $4 per unit and faces a perfectly elastic demand curve for its product. This also means that the firm's demand curve is a horizontal line drawn at the market price level. Moreover, this means that the firm's marginal revenue curve is the same as the firm's demand curve. Every time a consumer demands one more unit, the firm sells one more unit and revenue increases by exactly the same amount equal to the market price. In this example, every time the firm sells a pack of raspberries, the firm's revenue increases by $4. Marginal cost at first declines as production increases from 10 to 20 to 30 to 40 packs of raspberries in this graph, which represents the area of increasing marginal returns that is not uncommon at low levels of production. At some point though, marginal costs start to increase, displaying the typical pattern of diminishing marginal returns. If the firm is producing at a quantity where marginal revenue is larger than marginal cost, like at the quantity level 40 or 50 packs of raspberries, then it can increase profit by increasing output because the marginal revenue is exceeding the marginal cost. If the firm is producing at a quantity where marginal cost is larger than the marginal revenue, like at the quantity level 90 or 100 packs, then it can increase profit by reducing output because the reductions in marginal cost will exceed the reductions in marginal revenue. The firm's profit maximizing choice of output will occur where marginal revenue equals marginal cost, or at a choice closest to that point. In this example, the marginal revenue and marginal cost curves crossed at a price of $4 and a quantity of 80 packs of raspberries. The profit maximizing choice for a perfectly competitive firm will occur at the level of output where marginal revenue is equal to marginal cost, that is where MR equals MC. This occurs at Q equals 80. Does maximizing profit, which means producing where marginal revenue equals marginal cost, imply an actual economic profit? The answer depends on the relationship between price and average total cost, which is the average profit or profit margin. If the market price or marginal revenue is higher than the firm's average cost of production for that quantity produced, then the profit margin is positive and the firm will earn profits. Conversely, if the market price or marginal revenue is lower than the average cost of production, the profit margin is negative and the firm will suffer losses. You might think that in this situation, the firm may want to shut down immediately. Remember, however, that the firm has already paid for fixed costs such as equipment, so it may continue to produce for a while and incur a loss. Let's take a look at an example of our raspberry farm with three possible scenarios. A, where price intersects marginal cost at a level above the average cost curve. B, where price intersects marginal cost at a level equal to the average cost curve. And C, where price intersects marginal cost at a level below the average cost curve. In A, price intersects marginal cost above the average cost curve. Since price is greater than average cost, the firm is making a profit. In the second scenario, price intersects marginal cost at the minimum point of the average cost curve. Because price equals to average cost, the firm is breaking even. In the third situation, price intersects marginal cost below the average cost curve. Since price is less than average cost, the firm is making a loss. We will look into details for each graph. First, let's consider a situation where the price is $5 for a pack of frozen raspberries. The rule for a profit maximizing perfectly competitive firm is to produce the level of output where price equals marginal revenue equals marginal cost. So the raspberry farmer will produce a quantity of approximately 85 units, which is labeled as E prime in this figure. The farm's total revenue at this price will be shown by the rectangle from the origin over to a quantity of 85 packs, the base, up to point E prime, the height, over to the price of $5 and back to the origin. The average cost of producing 85 packs is shown by point C, or about $3.5 per pack. Total cost will be the quantity of 85 times the average cost of $3.5, which is shown by the area of the rectangle from the origin to a quantity of 85 up to point C, over to the vertical axis and down to the origin. The difference between total revenues and total cost is profit. Thus, profits will be the blue shaded rectangle on top. We calculate this as profit equals total revenue minus total cost. We take 85 times $5 for total revenue. Then we take 85 times $3.5 for total cost. So the profit is $127.5. Now consider a situation where the price has fallen to $2.75 for a pack of frozen raspberries. Again, the perfectly competitive firm will choose the level of output where price equals marginal revenue equals marginal cost, but in this case, the quantity produced will be 75 units. At this price and output level, where the marginal cost curve is crossing the average cost curve, the price the firm receives is exactly equal to its average cost of production. We call this the break-even point. The rectangles represent total revenue and total cost are the same. Thus, the firm is making zero profit. In the third scenario, the market price has fallen still further to $2 per pack. At this price, marginal revenue intersects marginal cost at a quantity of 65 units of frozen raspberries. The farm's total revenue at this price will be shown by the large shaded rectangle from the origin over to a quantity of 65 packs, the base, up to point E double prime, the height, over to the price of $2 and back to the origin. The average cost of producing 65 packs is shown by point C double prime, or about $2.73. Total cost will be the quantity of 65 times the average cost of $2.73, which is shown by the area of the rectangle from the origin to a quantity of 65 up to point C double prime over to the vertical axis and down to the origin. It should be clear from examining the two rectangles that total revenue is less than total cost. Thus, the firm is losing money and the loss or negative profit will be the rose-shaded rectangle. To calculate the loss, first we take 65 times $2 for total revenue. Second, we take 65 times $2.73 for total cost. Finally, take total revenue minus total cost, we get negative $47.45. This is the loss. To sum it up, if the market price that perfectly competitive firm receives leads it to produce at a quantity where the price is greater than average cost, the firm will earn profits. If the price the firm receives causes it to produce at a quantity where price equals average cost, which occurs at the minimum point of the average cost curve, then the firm earns zero profits. Finally, if the price the firm receives leads it to produce at a quantity where the price is less than average cost, the firm will suffer losses. The possibility that a firm may suffer losses raises a question. Why can the firm not avoid losses by shutting down and not producing at all? The answer is that shutting down can reduce variable costs to zero, but in the short run, the firm has already paid for fixed costs. As a result, if the firm produces a quantity of zero, it will still make losses because it will still need to pay for its fixed cost. Therefore, when a firm is experiencing losses, it must face a question: should it continue producing or should it shut down? If a firm shuts down, it will lose its revenue. However, the benefit of shutting down is saving costs. Firms do not have to pay variable costs when it shuts down in the short run. Please keep in mind that it still has to pay fixed costs in the short run. The firm should shut down if the benefit of shutting down is higher than the cost of doing so. That means it should shut down if total revenue is lower than its variable cost. We can divide both sides of this equation by the quantity level to write the firm's decision rule as price is lower than average variable cost per unit. Let's go back to the example of a raspberry farm that we had before. At a price of $2 per pack as graph A illustrates, if the farm stays in operation, it will produce at a level of 65 packs of raspberries, and it will make losses of $47.45 as explained earlier. But the price is above the average variable cost, so it continues to operate. In graph B, when the price drops to $1.5, this farm could produce 60 packs of raspberries. Total revenue is $90 and total cost is $165 for overall losses of $75. Because the price is below the average variable cost, shutting down is preferable to selling at a price of $1.5. The intersection of the average variable cost curve and the marginal cost curve, which shows the price below which the firm would lack enough revenue to cover its variable costs, is called the shutdown point. If the perfectly competitive firm faces a market price above the shutdown point, then the firm is at least covering its average variable cost. At a price above the shutdown point, the firm is also making enough revenue to cover at least a portion of fixed costs, so it should limp ahead even if it is making losses in the short run, since at least those losses will be smaller than if the firm shuts down immediately and incurs a loss equal to total fixed costs. However, if the firm is receiving a price below the price at the shutdown point, then the firm is not even covering its variable cost. In this case, staying open is making the firm's losses larger, and it should shut down immediately. To summarize this section, we can divide marginal cost curve into three zones based on where it is crossed by the average cost and average variable cost curves. We call the point where marginal cost crosses average cost the break-even point. If the firm is operating where the market price is at a level higher than the break-even point, then price will be greater than average cost and the firm is earning profits. If the price is exactly at the break-even point, then the firm is making zero profits. If price falls in the zone between the shutdown point and the break-even point, then the firm is making losses but will continue to operate in the short run since it is covering its variable costs and more if price is above the shutdown point price. However, if price falls below the shutdown point, then the firm will shut down immediately since it is not even covering its variable cost. One thing I want to point out right here is that for a perfectly competitive firm, the marginal cost curve is identical to the firm's supply curve starting from the minimum point on the average variable cost curve. To understand why this perhaps surprising insight holds true, first think about what the supply curve means. A firm checks the market price and then looks at its supply curve to decide what quantity to produce. Now, think about what it means to say that a firm will maximize its profits by producing at the quantity where price equals marginal cost. This rule means that the firm checks the market price and then look at its marginal cost to determine the quantity to produce and make sure that the price is greater than the minimum average variable cost. In other words, the marginal cost curve above the minimum point on the average variable cost curve becomes the firm's supply curve. Please keep in mind that it is impossible to precisely define the line between the short run and the long run with a stopwatch or even with a calendar. It varies according to the specific business. Therefore, the distinction between the short run and the long run is more technical. In the short run, firms cannot change the usage of fixed inputs, while in the long run, the firm can adjust all factors of production. In a competitive market, profits are a red tape that incites businesses to charge. If a business is making a profit in the short run, it has an incentive to expand existing factories or to build new ones. New firms may start production as well. When new firms enter the industry in response to increased industry profits, it is called entry. Losses are the black thundercloud that causes businesses to flee. If a business is making losses in the short run, it will either keep limping along or just shut down, depending on whether its revenue are covering its variable cost. But in the long run, firms that are facing losses will cease production altogether. The long-run process of reducing production in response to a sustained pattern of losses is called exit. If a firm exits the market, it will lose total revenue, but it will save all the cost. So a firm will exit if the benefit of exiting is higher than the cost of doing so. Or we can say the condition for exiting is when total revenue is smaller than total cost. We can divide both sides by the quantity level to write the firm's decision rule as price smaller than average total cost per unit. The combination of many firms entering or exiting the market will affect overall supply in the market. In turn, a shift in supply for the market will affect the market price. Entry and exit to and from the market are the driving forces behind a process that in the long run pushes the price down to minimum average total cost so that all firms are earning a zero profit. To understand how short-run profits for a perfectly competitive firm will evaporate in the long run, imagine the following situation. The market is in long-run equilibrium, where all firms earn zero economic profits, producing the output level where price equals marginal revenue equals marginal cost, and price equals average cost. No firm has the incentive to enter or leave the market. Now, let's say that the product's demand increases, and with that, the market price goes up. Therefore, the existing firms in the market will now be earning economic profits. However, these economic profits attract other firms to enter the market. Entry of many new firms causes the market supply curve to shift to the right, as you see in the top left graph. As the supply curve shifts to the right, the market price starts decreasing, and with that, economic profits fall for new and existing firms as shown in the top right graph. As long as there are still profits in the market, new entry will continue to shift supply to the right. This will stop whenever the market price is driven down to the zero profit level, where no firm is earning economic profits. Short-run losses will fade away by reversing this process. Say that the market is in long-run equilibrium where everyone has zero profit. Then, for some reason, demand decreases, and with that, the market price starts falling. The existing firms in the industry are now facing a lower price than before. They will now be making economic losses. Some firms will continue producing where the new price equals marginal revenue equals marginal cost, as long as they are able to cover the average variable cost. Some firms will have to shut down immediately as they will not be able to cover their average variable cost and will then only incur their fixed cost, minimizing their losses. Exit of many firms causes the market supply curve to shift to the left as shown in the lower left graph. As the supply curve shifts to the left, the market price starts rising and economic losses start to be lower as shown in the bottom right graph. This process ends whenever the market price rises to the zero profit level, where the existing firms are no longer losing money and are at zero profit level again. In conclusion, while a perfectly competitive firm can earn profits or have losses in the short run, in the long run the process of entry and exit will drive the price in perfectly competitive markets to the zero profit point at the bottom of the average cost curve, where marginal cost crosses average cost, which is also where firms are most efficient in order to cope with the highest level of competition. Finally, when profit-maximizing firms in perfectly competitive markets combine with utility-maximizing consumers, something remarkable happens. The resulting quantities of outputs of goods and services demonstrate both productive and allocative efficiency. Remember that productive efficiency means producing without waste, so that the choice is on the production possibility frontier. In the long run, in a perfectly competitive market, because of the process of entry and exit, the price in the market is equal to the minimum of the long-run average cost curve. In other words, firms produce and sell goods at the lowest possible average cost. Allocative efficiency means that among the points on the production possibility frontier, the chosen point is socially preferred, at least in a particular and specific sense. In a perfectly competitive market, price will be equal to the marginal cost of production. Think about the price that one pays for a good as a measure of the social benefit one receives for that good. After all, willingness to pay conveys what the good is worth to a buyer. Then think about the marginal cost of producing the good as representing not just the cost for the firm, but more broadly as the social cost of producing that good. When perfectly competitive firms follow the rule that profits are maximized by producing at the quantity where price is equal to marginal cost, they are thus ensuring that the social benefits they receive from producing a good are in line with the social cost of production. In conclusion, perfect competition in the long run is a hypothetical benchmark for market structures such as monopoly, monopolistic competition, and oligopoly, which are more frequently observed in the real world than perfect competition. Firms will not always produce at the minimum of average cost, or will they always set price equal to marginal cost. Thus, these other competitive situations will not produce productive and allocative efficiency. Moreover, real-world markets include many issues that are assumed await in the model of perfect competition, including pollution, inventions of new technology, poverty which may make some people unable to pay for basic necessities of life, government programs like national defense or education, discrimination in labor markets, and buyers and sellers who must deal with imperfect and unclear information. We explore these issues in other videos. However, the theoretical efficiency of perfect competition does provide a useful benchmark for comparing the issues that arise from these real-world problems. Thanks for listening. Bye for now and see you in the next videos.